time, and with reference to a stationary object. So then that object is said to be in a state of motion. Getting it? For example, you have a given boy standing over here. Now that
Can we send all the notes now?
you are going to send the notes.
Yes, sir.
Okay. You can send it if you have prepared it. That will be good. I will check that how you have made your notes. Okay. So Fatima, I'm saying that, and Razan, we learned when an object will be, or when a body will be said to be in motion. So when it will continuously change its position with respect to time. So in changing its position from A to B, it will take some time. It is going to take some time, right? So when an object changes its position with respect to time, then it is said to be in motion. Then there were various types of motion, like we have rectilinear, circular, periodic motions were there. So we learned about such types of motions. Also, we did learn about rotational motions, right? Then about measurement of time also, we have learned how people in the early days used to measure time with the help of some very traditional instruments or traditional methods which they had, like by looking at the position of the sun in the sky and the stars in the sky. Okay, and with the help of the sundial, the water clock, etc. Okay, they also had the stop clock. Basically, the sand clocks were also used. Further, we learned about the modern devices used for measurement of time. So we have got watches, clocks. Basically, they are of two types: analog and the digital ones. Okay, we had also learned about the time format, the 24-hour format and the 12-hour format. Further we talked about the speed. So speed basically tells us about the rate at which a given body would be moving. Okay, like speed basically tells you how fast or how slow an object is moving. We learned about that, and how we can calculate that we have learned about this. Particularly, how you can convert a speed from one unit to another, like how you can convert it from meter per second to kilometer per hour, and how you can convert it from kilometer per hour to meter per second. And I guess this is what confuses you, Fatima. This is what you found difficult to understand. So the conversion thing will be doing that. Okay, good. Further, we learned about uniform and non-uniform motion also. Okay. Okay, before I explain, I need to know whether you guys are able to recall this. Tell me what is uniform motion and what is non-uniform motion.
Uniform motion.
So a motion going in a straight line is called a uniform motion.
Okay, but that is not the complete definition. Even I'm going in a straight line, but suppose sometime I'm walking fast, I'm walking slow, like I'm driving fast and then I apply the brakes. So that does not necessarily mean that if I'm moving in a straight line, I will always be doing uniform motion. Okay, Razan, you were trying to say something?
When an uniform motion means when an object moves in the same speed in a straight line, same distance, and covers same kilometer distance is known as uniform motion.
Okay. And what about non-uniform motion?
Non-uniform motion means an object that does not go in a straight line and like goes fast, then slow, like stops. It doesn't go in the same speed and does not cover the same distance and all.
Okay, see, very good. Fatima, you also explain about non-uniform motion.
Yes, sir, a line that does not go in a straight line, or it's going like it's stopping and then going fast, is called a non-uniform motion.
Okay, so basically its speed will keep on changing, right?
Yes, so if the speed is going fast and slow, it's called a non-uniform motion.
Good. So basically in uniform motion, an object will be moving with a constant speed and will travel equal distances in equal interval of time, right? Equal distance in equal interval of time. Okay, so everyday life we find that all different objects would be moving with a different speed. Getting it? Like if I'm riding the vehicle in the traffic, so my speed will keep on changing. Okay, but when I will be moving on a straight road with a constant speed, so my speed will be said to, I will be said to be doing a uniform motion. Okay. Further, we have learned about the working of the pendulum. In the case of pendulum, we had learned about oscillation and all that, and how we can calculate the time period of the simple pendulum. So we'll be doing some numerical questions from the simple pendulum also. Further, we have learned about the distance time graph of uniform and non-uniform motion. I will be drawing some distance time graph. Okay. You guys have to tell me, out of the 1 and 2, which one is the graph of a uniform motion?
Sir, the first one.
First one.
First one, exactly. The second one is for?
Non-uniform motion.
Exactly. Okay. So we'll be learning about these things also. Then what do you guys know about speedometer or the odometers? You might have seen this mounted on the front part of the cars or the vehicle.
Can I see the formula of speed?
Repeat again, formula for?
Speed.
Speed is calculated by dividing the distance by time.
Yeah,
Speed.
like I asked, can I say?
Oh, sorry. I thought you were asking. My bad. Okay. So, okay, I have already told the formula, that is speed equals to distance upon time. Now, how would you calculate the distance if speed and time is given? You can tell this one. I'm saying that, how do you find distance if speed and time is given to you? Yeah, Fatima, you also have to answer. Why don't both of you turn your cameras on? I feel like I'm talking to no one. Like this is just some voices. Yeah. How do we calculate distance?
Time by speed
No.
or speed by time?
No.
Kilometer.
No, I'm not asking for the unit formula.
Oh.
Formula, no. It's distance. Distance equals to speed multiplied by the time. Speed multiplied by the time. Okay, now? Basically, you all also should understand, like, how did we got this formula? So distance equals to speed upon time. D for distance, S for speed, T for time. Can I also write down this, that speed is equal to, I will move T from this side to this side. T here is in division with speed now, right, Fatima? Right, Razan? So when I will move it from this place to this place, then it will go in multiplication with distance. So hence speed is equal to distance multiplied by time. Got it now? Yes or no? See, there is one important thing I would like to convey to both of you. See, whenever, whether you are studying from me or from anyone, whenever you find any concept difficult to understand, keep on asking to the teacher, keep on asking until your concept is clear. So never hesitate in asking questions. Don't feel shy in asking questions. Okay, now, person who feels shy in asking question will always find difficult to understand the concepts and will find herself or himself in a kind of confused state. Okay. Yeah. So you guys tell me, what is speedometer and odometer?
What's that?
What is
Sir, I
speed?
don't understand what it means. Can you explain?
This speedometer.
Yeah, and odometer.
Okay.
So can I say what speedometer is?
Yeah, you can.
Speedometer means like it shows you the speed that you're going on in the vehicle.
And the
Odometer
odometer tells us how far the vehicle has traveled, how much of distance has been traveled by the vehicle.
Yes.
Okay. Take a look at this, Fatima. Okay, now see this thing that you see over here. Okay, where 20 kilometer per hour, 40 kilometers, 60 kilometer per hour, or kilometer per this 140 kilometer per hour. So you take a look at this needle.
Yeah.
When we will be speeding up the vehicle, the needle will start to move. It will go from 0 towards 140. So wherever the needle would be pointing, it will be telling you the current speed at which the vehicle is moving. So this one is called as speedometer. On the dashboard of the car, you can see this. Okay.
Yes.
But nowadays, like this is kind of being replaced by the digital. We have the digital dashboard on the car nowadays, right? We get the digital numbers. Okay. But still, in some cars, we find this. And take a look at this one here. This one is the odometer, right? So on the dashboard, both the devices are installed on the dashboard. The speedometer will tell you the current speed at which the vehicle is moving, and the odometer will tell you how far, like how much of distance the vehicle has traveled. Getting the difference, both of you?
Yes, sir.
Fatima, getting it, no?
Yes, sir.
So we will start off by some questions. Basically, we will first do a little bit of revision, and then we will continue with this. Okay, so your first doubt was regarding conversion. Okay, now let us understand this. See, I can just give you the shortcut formula, the number which you have to memorize. But you also need to understand that how do we convert the speed from meter per second to kilometer per hour, or back from kilometer per hour to this. Okay, I can give you a very shortcut formula. That is, you simply, whatever is the speed in meter per second, you multiply it by 3.6, you will get the answer in kilometer per hour. Okay, no? But you also need to know the background, like how we came to this value. Getting what I'm trying to say? Yeah.
Yes,
So to convert meters per second to kilometer per hour, you have to use the following formula. That you simply multiply the value, 1 minute, whatever is the speed in meter per second, you multiply that by 3.6. 3.6. So we see that 1 meter per second, 1 meter per second in terms of kilometer per hour is going to be 3.6 kilometer per hour. What can you say about 2 meter per second? Yeah. Tell me, what will 2 meter per second be equal to?
3.6 kilometer per hour.
No, 2 meter per second I'm saying, no. Just now I told you have to multiply it by 3.6.
We have to multiply 2 into 3.6.
Exactly. That will be equal to?
1 minute.
Both of you do the multiplication. Fatima, you're going to school regularly now? What's going on in the school right now?
Sir, we finished mostly all the chapters, so we are just practicing, or either we have few periods.
Sir, is it 7.2?
Okay, exactly. That is 7.2. Okay, no?
What do I have to multiply right now?
Yeah. What we did here now, see, the speed here was in meter per second, it was 1 meter per second. So speed in meter per second given to us was 1 meter per second. You multiplied by 3.6, and thereby you got the value as 3.6 kilometer per hour.
Yes.
So if the speed given here is 2 meter per second, so you have to multiply 2.
So, sir, everything we have to multiply it by 3.6.
Exactly. No matter if it's a whole number, if it is a fraction, if it is a decimal, whatever kind of number is given, you just have to multiply it by 3.6. Hope you're getting it.
Yes.
So here it is going to be 7.2 meter per second. I'm going to give one question. Okay. You guys do this question number 1. If a car moves at this speed, then its speed in kilometer per hour is going to be how much? Both of you are going to answer separately in the chat box. I want both of you to participate. Okay, you guys know where you have to answer. Now, let me drop one message. Here you have to give your answers.
Sir, if we have to multiply by 3.6, why did you write 7.2?
Repeat again, Fatima.
If we have to multiply it by 3.6, why did you write 7.2?
No, I'm saying that we converted 2 meter per second into kilometer per hour. No. So, oh, sorry, I've written meter per second. No.
Yeah.
This one, oh, sorry. Accidentally, I wrote that. Okay, thanks for pointing out this. So 7.2 kilometer per hour. Okay. Continue. Razan, were you saying something?
No, sir.
Okay, continue. No, that is not the right answer, Razan. In the 5th grade, you must have learned about decimals. How do you multiply a whole number with a decimal? Let me give one example. Suppose that you have two numbers. Let us just say you have 100, then you have assume another number. Let us say you have 7.8, let us suppose. Okay, now we need to do the multiplication here. What do? We can do the multiplication considering that they are normal numbers. Like this is a normal natural number, only 78, not 7.8. So after multiplication, your answer would be 7,800, 7,800, right? Now, there's a decimal number also here now, right? So after the decimal point, how many digits are there? Only one now. After this decimal point, that is the decimal point we are having here. After this, how many digits are there? One. So starting from the right, you're going to put a decimal point after one digit. Getting it? So this one is going to be 780. Okay, now 780. Got it?
So there won't be any decimal point?
No, you don't write the decimal point. You simply write it as 780. No, Razan, even now it is not correct. No. The value given here is 10 now. You need to, what do we need to do? You guys tell me. Multiply it by
Multiply 3.6.
3.6. So multiply it.
Oh, okay, sir. I didn't understand.
Not getting it. Fatima, what about you?
No, sir. I got the answer. I'll type it in the chat box.
Okay. Fatima,
Yes,
you can
sir.
you can ask me if you're finding it difficult to calculate.
Yes, sir.
Should I explain this to you?
Yes.
Okay. So suppose you have 8.6. I'm not going to take the same number. You're going to do it, but I will be changing the number. So suppose you have 10 multiplied by 7.9, suppose. Okay. What you need to do, just multiply them normally. So this will be equal to 790 after multiplication, right? Now, in the given number, how many digits are there after the decimal point?
One.
Only one, no?
Yes.
So starting from the right side of the number, you will put a decimal point after one digit, right? Meaning that after 0, you're going to put a decimal point. So that is 79.0, but the right way to write this is, correct way is simply write down this as 79. Getting it now?
Yes.
Okay, can you tell me what will be the answer to this 10 multiplied by 8.8?
Okay.
Here is, and now it is correct. Yes, I'm waiting.
Sir, it's 88, right?
It's 88, exactly. So this is going to be 88. So similarly, this one is going to be 36 over here, right? So 36 kilometer per hour is the right answer. Got it, no, both of you? Good. If you have got it, that's a good thing.
Sir, can you have the 36 came?
Can we have that 36?
Can you tell how the 36 came?
Okay, sure. See,
Is it cause the 3.6 equals 36 because we multiplied by 10?
because we multiplied by 10, thereby we are getting 36. Okay.
Oh.
So we had this number multiplied by 10. Okay. So let's multiply them as normal number, non-decimal numbers like natural number. So this is simply going to give us 360 after multiplying. So we write down 360, but we see that there is a decimal number over here and there is one digit after the decimal point. So starting from the right side of the number, you place a decimal point after one digit. So that is 36.0, but correct way to write down this is 36. Getting it now?
So, sir, if we see any number that is being multiplied by 10, we should know just it's the same answer, but without the decimal point.
Yeah, it like in a general way also see if it is being multiplied by 10, it is going to be same. But if it were to be multiplied by suppose 100, okay, so then it would be a different answer. Getting it? That would be 360. How? Let us learn that also. So you multiply 36 with 100. As I told you, just multiply it as natural number. Okay, now remove the decimal point and then do the multiplication. So this will you will be getting a 3600, right? Now count the number of decimal digits. Like count the number of digit after the decimal point. Only one now. So we are now going to move in the right direction, and after one digit, you're going to put the decimal. So that is 360.0, but we write down this correctly as 360. That's how it came. Okay. So the quick way to convert from meter per second to kilometer per hour is to multiply it by
3.6.
3.6, exactly. But when you do the opposite now, you're going to divide it.
Divide with 3.6?
Divide it by 3.6. If you haven't written this earlier, write down this. Okay. Write down this fast. Fatima, you? Meanwhile, you guys answer these questions also. 1 kilometer is equal to how many meter? How many meter?
1,000 meter.
Repeat again. One kilometer equals to how many meter? Yeah, Fatima, Razan. See, it's simply 1000 meter. Okay, now both of you memorize these things. Okay, and 1 meter has
1,000 meter.
1000 meter, and 1 meter equals to 100 centimeter. Okay, and 1 centimeter equals to 10 millimeter. Okay, as for the time, 1 hour simply equals to how many seconds? How many minutes?
60 minutes.
Obviously. And 1 minute equals to how many seconds?
60 seconds.
60 seconds. Now, if I were to talk, you guys tell me, 1 hour will be equal to how many seconds then?
120
60.
seconds.
Not 60.
Repeat again.
60, right?
No. 1 hour does not have 60 seconds.
Oh.
1 hour. It's second now.
120 minutes.
No. 120 minutes means 2 hours. No.
Oh, not 120 minutes.
Mhm.
So 90.
No. 90 seconds means 1.5 minute. 90 seconds means 1.5 minute. No.
I'm saying that.
Pay attention here. Look over here. First, we are going to convert this from hour into minute. We need to find how many seconds are there. No? So we convert hour into minute. So there are 60 minutes now. Obviously, 1 hour has 60 minutes. Now we know that 1 minute is equal to how many seconds? 60 seconds. 10 minutes. Yeah, 10 minute equals to, do the maths. 1 minute equals to 60 seconds. 2 minute equals to,
1 hour is equal to 12,000. 1,200.
no. Pay attention here. Pay attention to this. 1 minute equals to 60 seconds. Thereby 2 minutes is equal to
120 seconds.
120 seconds. Okay. 5 minutes. 5 multiplied by 60 doesn't be. Yeah, Fatima? That is 300 seconds. Okay. What about 10 minutes now? You're simply multiplying whatever time is given in minute, you are multiplying by 60 to get it in second. So 10 minutes multiplied by 60, 600 seconds. No? So similarly, here you are provided by 60 minutes now. So 60 minute multiplied by 60 is going to be how much?
6.
No. Do the multiplication carefully. 0 zeros are 0. 0 6 are again 0. We leave a blank space. 6 zeros are 0. 6 6 are 36.
360.
No.
36,000.
3600 now. Just add them. No. 0 0 6 and 3. It's going to be 3600. So 60 minute is basically equal to 3600 second. So 1 hour, can we say that 1 hour is equal to 3600 second? Is it a yes from both of you? Fatima, you getting
Yes,
it?
sir. Yes,
Good.
sir.
Okay, if you haven't written down these stuff, please write down this fast. Hold on, there's someone on door. I will be back.
Okay, sir.
Let's unpack. All right, so that was about the conversion of unit. Okay, so we have already converted from meter per second to kilometer per hour. Now we are going to do the opposite. Convert from kilometer per hour to meter per second. All right. So you guys take some questions. If a car moves at 36 kilometer per hour speed, then its speed in meter per second is equal to what? Okay, that's a simple question. You know what you have to do? What do we have to do, guys?
Divide by 3.6.
Exactly. So do the
Then
division.
multiplied by 3.6.
No. We're converting from kilometer per hour to meter per second. No.
Oh,
Question is, car is moving at 36 kilometer per hour speed. You have to convert this into meter per second. Okay. So do it. I hope you guys won't find difficult to division divided by a decimal number. For reference, I will do one question. Like if you guys tend to forget this, suppose you have 72. Okay, and you divide it by 3.6. Okay. You're getting this value. Okay, I will be checking. So say you have 72 and you divide it by 3.6. Okay. Now we will consider this as a normal number, suppose. Like it is 72 being divided by 36. Okay. So 72 divided by 36 is going to be 2. Yeah, it's going to be 2, isn't it? Okay. But here's the problem. Like the number is a decimal number, no? So the quotient you are getting, the answer you are getting, you will move in the right direction, and there has to be a decimal point in this, and after the decimal point there is only one digit here. So in the quotient also you will put a decimal point such that after the decimal point you have one digit. Getting what I'm trying to say? So 0.2 is the answer to this. Okay, now we can write this as 0.2. No, the answer is not correct, by the way. Okay, no?
It is
Then the
not
answer.
correct.
No, it is not correct.
36 divided by 36.
Mm-hmm. Okay, just 1 minute. You have the value is 36, no? Mm-hmm, it is correct. Good. Yes, Fatima, what about you?
I'm writing.
Okay. Meanwhile, you take one more question, Ruzan. If a car moves at a speed of, suppose, 144 kilometer per hour speed, then its speed in meter per second is how much? Okay. Yes, Fatima, done?
So I'm finding a bit difficulty. Can you explain it again?
Okay, sure. Consider you have one example. Okay, where you have a speed of let's assume it is given as 18 kilometer per hour, and we have
40
to
kilometers per hour. 40
meter per second.
meter.
Exactly. Always pay attention to the unit. So 18 kilometer per hour, suppose, has to be converted into meter per second. Okay, Razan, you can also do this question, but answer in the chat box. Okay. So this we know we need to divide it by 3.6 now. Okay, we have to divide this by 3.6. So 18 is being divided by 3.6. Now let's do one thing. How about we write down this in the following manner? 18. Let's convert 3.6 from decimal to fraction. So that is going to be 36 upon 10. Yes or no? We convert it from decimal to fraction. Like if the number in decimal is given as 3.6, you need to convert this into fraction. So you just write down it as a non-decimal number without the decimal point, then count the number of digits after the decimal point. There is one digit, so you will write 1 with 10 here. So that is 36.10. Okay, Fatima? Yes, Fatima?
Yes, sir.
You getting it? How you convert it from decimal to fraction?
Yes.
Good. Further, is it okay if I write 18 upon 1?
Sir.
It's okay now? Okay. I can write it in the following manner. Okay, like suppose you have given a number 5 and someone asks you to convert this into fraction. So you'll simply write down 5 upon 1. Okay, no? So I have written 18 as a fraction, like 18 upon 1. Now you guys know how to do how to divide two fractions. Now, the first fraction remains as it is, but the other fraction, like the numerator goes to denominator, becomes reciprocal, exactly. So 10 will go up and 36 will come down. So this is now 18 upon 1 multiplied by 10 upon 36. Hope you guys are getting it now. Getting it now. So 18 upon 1 multiplied by 10 upon 36. So this is 180 upon 36. So you divide 180 by 36. So this one I suppose you guys would be able to do. Yeah, Fatima, divide 180 by 36. Tell me what is the answer you'll be getting here. From here till here, is it clear to you, Fatima? Be honest and tell me. If you are not getting it, I will be happy to explain once again.
Sir, I don't know. It's just a bit confusing to understand.
Okay. Let me take a fresh page. Suppose, let's do the same question. The speed given was 18 kilometer per hour. What you had to do is to convert this into meter per second. What do we do?
Okay.
To
Meter
convert
per second, right?
Okay. Yeah, meter per second. So what do we need to do here? Multiply or divide by 3.6?
Divide.
Divided by 3.6 now? Good.
Yes.
So 18 is being divided by 3.6 here. Okay. In the second step, I am converting, like from here, it's all about maths. Okay, now the concept is to divide. Here we are doing the maths. So to write down it in the form of fraction. So 3.6 is written as 36 upon 10. Is this part clear? How we converted this into
Yes.
fraction? Good. Now I'm writing 18 also as fraction. 18 upon 1. Okay.
Okay.
Now from here on, what we know, suppose if you are given, no, that is not going to be that much of a value. No, divide it properly, Razan. The value given here is 180 and you have to divide it by 36. There's one extra zero in your answer. It is not supposed to be there. So in the roughest space, pay attention here, Fatima. Suppose if a fraction a upon b is given and you divide it by c upon d. Okay, na? A, B, C, and D are some hypothetical numbers, suppose. I don't know. Just these are two fractions. Wherever you will find difficult to understand, just raise your hand. Now, what we can do, we can write it in the following manner. A upon B. Now, the sign of division changes to multiplication. Okay. Division changes to multiplication. 1 minute.
Low or high?
Yeah, just hold on, Razan. I will be getting back to you 1 minute. C upon D will now be written as D upon C. Getting it, Fatima? C upon D is now written as D upon C. So same thing here we are going to do. 18 upon 1, convert the sign of division to multiplication. And 36 upon 10 will be written as?
Uh,
Match it from here.
10 by 30.
Exactly. Okay. Now, yeah, now it is correct, Razan. Good. From here on, you have to basically multiply the numerators. 18 multiplied by 10 here and 1 multiplied by 36. So what is that going to be? 180,
180 into by 36.
36. So we simply multiply it from here now. So 36 fives are 180. That's it. That's your question and that is your answer. So thereby it is 5 meter per second. Hope you're getting it now. Okay. Take a screenshot of this if you find it confusing. Yes, Razan, now you were saying something.
Thanks, sir.
Okay. So that is over. Let's continue with this. Is it clear to Fatima? It's clear.
Yes, sir.
You have an answer for this one, by the way. For third question. 144 kilometer per hour. Okay. Answer that. Okay. Meanwhile, you start solving the following question. Listen. A car is traveling, has traveled a distance of 150 kilometer in 3 hours. You need to calculate its speed. What is the formula to calculate the speed?
Distance by time.
Exactly. So apply the formula and find your answer. Write the unit also, no? Yeah. M should not be in capital, by the way. Okay.
There it's
No
by
issues.
mistake.
No issues. Now do the third question. Skip the second question as of now. Do the third question, Rizan. Yeah, Fatima done. You were so
No, sir.
okay. Okay.
Sir, send the answer.
For this one, let me see. Yeah, that one is correct. Very good. You have written the unit term. That is 8 meter per second. Good. Okay, Fatima, what about you? You're done with this question? 144 kilometer per hour. Yeah. Miss Fatima, you still there now? Okay. Just like you're not there. You need to find the speed. You need to find the speed. I will be drawing two graphs. You need to find the speed at which the vehicle is moving. Here's the time, and here we have the distance. Fatima, you there? So we need to find speed at A is equal to what, B is equal to what, and what is the speed at C. Fatima, you have got your answer or not?
Not yet, sir.
Not yet.
Sir, in our next class, can we
Mhm.
do some questions in transportation in animals and plants?
Yeah, surely we can do that. Okay. Getting back to the question which was assigned to you, it was 144 kilometer per hour. You have to divide it by 3.6. What's the update on this? So the basic things that you need to understand here, how do you convert a value from a decimal to fraction? 3.6 in fraction, it's 36 upon 10. There is one digit after the decimal point, no? You write 1 with 0 and 36 on the numerator, 36 upon 10. Then here you have 144. I have written this in the form of fraction. So I just write 1 in denominator. Okay. Just hold on 1 minute, Rizan, I will get back to you. So 144 upon 1 divided by 36 upon 10. From here on, we follow on this thing. It's 144 upon 1 divided by 36 upon 10. So Fatima, tell me the sign of division, I will be changing it to
Division.
The sign of
3.
division is changed to,
Multiplication.
and what will happen to 36 upon 10? It will be written as
3 point.
no. 36 upon 10 will be written as 10 upon 36. No.
Oh yes, yes.
No, it's 1440 divided by 36. Okay. I would say that you need to work on maths. Okay, now the calculation part, there you are stuck in. Okay, no? The concept you have understood, now what you have to do, where you have to do
Yes, sir.
multiplication
Understood.
using. You need to work on maths part. Okay, so 36, and here you have 100, 1440. Okay, so 36 8s are 144. Okay, so you have 0 over here, and 36 zeros are 0. 36 zeros are 0. Getting it? So thereby, the answer you'll be getting here is 80 meter per second. So that is 80 meter per second. Getting it now? So that's it for today's class. And for you, you're getting 2. No, for the B, for the A, it is correct. Fatima, you also pay attention here. At the point A, what is the distance at point A? 10 meter, no? And time, 5 seconds. So speed is equal to distance upon time. So thereby 10 upon 5, that is equal to 2 meter per second. That one is correct. For B, you are answering 11 meter per second. No. At B, the time is 10 seconds and distance is 20 meter. So that is going to be exactly 20 upon 10. That is again going to be 2 meter per second. And at the C point also, it's 30 divided by 15. That is again going to be 2. So each time speed is same. So what kind of motion is being done by the body if the speed is constant? Yeah, Fatima? Yes. I'm saying that what kind of speed, motion is being done by the object if each time speed is same? Uniform or non-uniform?
Uniform.
Uniform, no?
Yes, sir. Uniform.
Good. Okay, see, we are not done with this. There are many questions that you guys need to do. So Fatima, as part of today's assignment, I will be giving you guys some numerical questions. Okay. And I want you guys to solve it before the next class and
Where
upload it
you'll
on
be
the website.
sending it?
Basically, it will be uploaded there on the website.
Oh.
Okay. Okay, so that's it for today's class. And stay consistent as the exams are near. Sometimes you guys are present,
Yes.
sometimes you're absent. So that is not a good thing. Okay, consistency is important. Okay, so that's it for today's class then. Okay.
Allah Hafiz, sir.
Allah
Thank
Hafiz.
you.
Walaikum Assalam. You're welcome.
Assalamu alaikum, sir.
Yes, Walaikum Assalam, Halima. How are you doing?
I'm fine, sir. How are you?
Yes, Alhamdulillah, I'm also good. Okay, so we had started the revision of the chapter sorting materials into groups. So some of the things we have already discussed in the previous class, like how we can sort materials into different groups based on the hardness, based on the luster property. Okay. Further, based on whether they are transparent, translucent, or opaque objects. Okay. Also based on the solubility in water, also we have categorized them as soluble and insoluble substances. Okay. Also we have learned about conductors and insulators. So first method of sorting, it was based upon the appearance. We have lustrous and non-lustrous objects. Next
Yes.
was hardness.
Hardness
Based on-
and soft.
Exactly. So based on hardness, like there are two types of materials are there. One that is hard, another one that is soft. So materials
Yeah.
that can be easily compressed or could be stretched. So they are hard objects. I mean to say cannot be easily compressed or stretched. So they're hard objects. Like, can you compress a piece of rock in your hand?
No.
No, getting it. And as for the soft objects like the rubber,
Sir,
wood,
like hard substance be like marble.
marble, yeah, like that. Okay, no? Okay, Ayush is here. By the way, you guys check your WhatsApp messages. I have sent the PPT for the chapter electricity. Did you guys got it or not?
Yes, sir, I got it.
Got it? Good. Okay. Can you see the notes written there or not? The notes. Many times what happens now, there's some, due to some error, no? The I do write
It will
the
be
notes.
sometimes blurred.
Yeah, sometimes it would be
Yeah.
blurred or sometimes it would be erased.
Yeah,
Okay.
yeah.
But this time I think it should be visible.
Yes, sir.
Mhm. I think that happens now when I include some animations in the slide, no? So that problem occurs in such a situations. Okay. Anyways, yes, Ayush, how are you?
Fine, sir.
Good. So we learned about these things. Further, we also learned that there are certain kind of objects that would be floating while some would be sinking into the water. So this was related to the density of the materials. So what is density? So density in very simple terms is how much stuff is packed into a certain space. How much of stuff is packed into a certain space. So imagine you have two boxes, but both of them are of the same size. Imagine you are having two boxes in your hand, both of them are the same size. One of them is filled with cotton and the other one is filled with the iron. So which one will be heavier? Yeah,
Iron.
exactly. Why is it so? Because iron has got,
Because iron has more mass.
exactly, iron has more mass in it. Getting it now?
It is basically heavy.
It is heavier, it has more mass in it, since so it is just heavier, and thereby since it has more mass, it is also having more density. So we had taken two boxes, both of them are of the same size. What is this shape? Is it cube, cuboid? What is it?
Cube.
Cube. Are all the sides of a cube equal?
Yes.
Good. So both of them are packed. This one is packed with some cotton, and this one has been packed with iron.
Yeah.
Okay. So this one is having more mass, and this one is having
That is less mass.
less mass.
So cotton will be a bit light.
Hmm. Okay, both of you turn your cameras on. So density, as we were learning that, it basically tells us how much of stuff is packed into a certain given space, into a certain space. So the
Sir,
density of cotton, we will say it is lighter. The density of iron will be more. Yeah, Halima.
so there is one question I have.
Mhm.
If there will be 1 kg of iron and 1 kg of cotton, which will be heavy?
Okay. If you have 1 kg of iron and 1 kg of cotton, which will be
Cotton.
heavy?
Yeah.
See, in terms of heaviness, both of them are equal. In terms of heaviness, both of them are equal now. They will be equally heavy. Getting it? But if you were to think of this like which one will take more space, so obviously cotton will take more space. Like 1 kilogram of cotton will be stuffed in a big bag like this. That is 1
Sir,
kg.
density?
Density, in terms of density, obviously it is going to be iron. Why iron? Like
Yeah.
you have a weighing. For example, this is a piece of iron object. That is 1 kilogram. So look at the size of the two. 1 kilogram of cotton is taking a very big space, while 1 kilogram of iron takes a very small space. So much of mass is packed into such a small space. So it is going to have more density. Hold on, someone's on door. So I'm back. So as we were learning about this density, so density tells you how much of stuff is packed into a given area, given space, basically. So although both of them are having same amount of mass, but in this small area, so much of iron is packed. So thereby iron will have more density. It will feel heavier. Although both of
Yeah.
them are equally heavier, right now? But when you hold it in your hand, it will feel very heavy. But they are equally heavy although. So
Okay,
that is the case about density. So in terms of density,
both of them are heavy.
iron have
I mean, iron have more
more
dense.
density, but cotton has
Less.
less density. Getting it? So if I were to take this bag of cotton and if I were to throw it in the water, it will not sink easily because of less density. But this
Mm.
iron will immediately sink into the water body.
Sir,
So
for
density.
example, there was one question for me in pre-cap in this question only. Why will if we put cotton in water, will it sink or float? So after some, like, if we put cotton in water, first it will flow
But
on
then it will
water,
sink.
but then it will sink because it will absorb water.
Exactly. It will absorb water, will become heavy, and then will sink. Okay, no? That is one thing. So you will see that a stone will be sinking while the feather will not sink very easily. It will float for some time because of the difference in the density. Okay, no?
Sir,
So with
there
it,
was one more question.
Mhm.
Why iron sink? I mean, iron nail sink and iron ship float.
that is also related to the density. Okay, no? The reason why an iron nail would be sinking, but a ship made up of iron would be floating, it is because of the density. Also, one of the main reason is because of the shape. Okay, no? A ship is hollow from inside, no? Right? So the shape of the ship is allowing it to displace more water also. Okay, no? So we'll be getting back to this, but let us get back to this topic right now, like why some objects are floating and sinking in water. So materials that have less density than water, it floats. Like you would see that oil floats on water, no? Yes, Ayush, oil floats on
Yeah,
water. Why does it float?
because it is like it's not heavy.
It is having less density than water. Okay.
Okay, yeah.
Ayush, are you getting the concept or not? If you're finding anything difficult to understand,
No, sir,
okay.
I'm getting.
Getting it now? Okay. Halima and Ayush, both of you turn your cameras on. Okay.
Oh, yes, sir, only 1 minute.
Okay. So materials that have more density than water will sink to the bottom. As here the coin is more denser than water, it feels heavier, so it will sink into the bottom. While the core could be basically floating on the water. So all of it has got to do with the density. Okay. Now there is one more important topic. That is the buoyancy. Buoyancy. Okay. Like the upward force applied by the water on the object or any on the object, or we also when we go into the water, so we feel an upward force applied on our body. Getting it now? So the upward force applied by the water on the object or the body when an object is put in or submerged into the water, that is called as buoyancy. Has it ever happened like you guys went to a swimming pool? Okay. How many of you know swimming?
Me.
You know? Good. So when we go into the swimming pool, so we feel an upward force on our body, as if the water is applying a force on your body in the upward direction.
Yeah.
Have you guys felt that? So that is also one of the reasons why certain things should be floating. Okay, now. So consider this thing that you have a given object. Okay, its weight is equal to the force applied on it, equal to the force of buoyancy. It's equal to the buoyant force, so it is going to float. But if the weight of that object is more than the force applied on it, more than the buoyant force, so then it is going to sink. What is buoyant force? The upward force applied by the water on the body. Is this thing clear?
Yes.
Okay, no? So here you can see this piece of wood is floating because its weight is equal to the buoyancy applied on it, the force, upward force applied on it. So materials can be classified based on the sinking or floating in water. So a leaf would be floating on water, or the metal spoon will be sinking into the water. That is one thing.
Yeah.
Okay. Now, take a look at the structure of a ship and that of an iron nail. Hold on. So this is an iron nail. Is iron nail hollow from inside?
No.
Obviously no. But when you take a look at the structure of the ship, okay, no? So ship is kind of, let me draw a simple ship like this.
Yeah.
And it is also made up of iron or steel. Assume that this is also made up of this thing. Now we see that it is hollow from inside, isn't it?
Yeah.
It is hollow from inside. Now, like this is the hollow space in it. Getting it? So we see that it is basically having air inside it, right? So the air inside the boat / ship makes it less dense.
Less than.
Less dense. Getting it? So thereby, the overall density of the ship or the boat is less than the water. So thereby, it is
Water.
going to float. But
Float.
here, it does not have any air inside it. Okay, no? It is completely filled with iron in it. Okay.
Yeah.
So thereby, it is going to sink. So it is denser
Denser
than
than the
water.
water.
Okay, no? So we are saying they're more denser than water. But here, this is less denser than water.
Less denser than water.
Okay, so something that is less denser than water, it floats, and something that is more denser than water, it is
More
going to sink.
Sink.
Getting it now? Hope it clears the concept, right?
Yes.
So we see that an iron nail sinks as it has more density, whereas
So this is
ship,
sorting out materials, no?
yeah, obviously sorting of materials.
Okay.
Okay, so whereas a ship made up of iron or / steel is hollow from inside, and has less density,
Floats.
thereby floats. Okay, thereby it floats. That is the thing. Okay. So as for the density, we have learned. Okay. One more important thing here. That was about all this. Now talk about the solid object, liquid object, and the gaseous object. So if you were to take a look at the particles of the solid object, like these are all glass beakers, all of them are of the same size.